Am I audible to everyone? Okay. So yeah, I think we had a gap in between, right? I was little busy those days, so that's why we had no any sessions. Okay, so sorry for that. And yeah, so we'll make sure that we will not take any gaps now. Okay, cool. So yes, we had a session, the last session about the uh, decision tree, right? Uh, we have seen some of the uh, practical example for the decision tree. Sorry, the theoretical practical, basically the calculation we have seen, right? So far, so soon, we have seen those things, right? And today, basically, we are going to implement the same things, okay, practically in the Python, right? So I hope you all remember that logistic regression and also the decision tree, right? So can anyone tell me the brief about the decision tree? So we'll get to know that yeah, you all are aware about that. How decision tree works? Anyone? You all remember or forgot the work, how it works, the decision tree? Yes, no, guys. Okay. So what is the two methods in a decision tree to decide the root node? Guinea and entropy. Okay. Yeah. I don't think so. Anyone remember the formula, right? Okay. No worries. We'll try to uh, tell you the formula as well. So we'll do the practical. Okay. So that will help you understand the things. Okay. So let's start with the practical, right? The things will be clear. Okay. So let's open your Jupyter notebook and let's start with it. You open my Jupyter notebook and then also I hope you all can do the code with me. Okay. So let's create a new notebook for the classification. Mm, let's call it as a classification because we are going to do the logistic as well as decision tree both in this. Okay. And going further, we can also see one more algorithm, which is the KNN. Okay. Uh, okay. So classification matrices. Anyone remember about it? Recall, precision, happen score. Yes or no? You remember that we have discussed about the classification matrices? Recall, precision, true positive, false positive, true negative, false negative, all these things. Let's know, guys. Yeah. Okay. So let's import the libraries first of all. So let's import the pandas and can call it as a PD, and we can import the numpy as well. Okay. Uh, this both library we need as of now and starting. So let's import it. Okay. And I'm going to share one URL with you that will give you your data. Okay. So let me share with all of you. I will explain you what is the data. Don't worry about it. Okay. Let me give you this particular URL first of all. I hope you all got it. Okay. So now we need one more library over here. Uh, the URL lib. Okay. Because we are going to scrap this data from the website. Okay. So import URL lib dot request. Okay. We can import this and I can paste this URL over here in a variable name URL. We can just run it. Okay. And we can retrieve this particular data from the URL. So it's pretty simple. URL lib dot request dot retrieve URL retrieve. Yeah. So you'll get the option, you will get the function URL retrieve. Inside that, you have to pass your URL and how you want to save the data. So it's basically a medical data. So we'll save it as a hard.csv. Okay. Hard.csv, I will save the file as a hard.csv. Okay. So once we'll run it, it will download the data. Okay. It will save here as a hard.csv. You all are able to see, right? Just 4 seconds ago, you got this particular data. Okay. So this is your URL lib. Okay. I think we have done this practical for a logistic and decision tree before because I don't remember. So that's why I'm asking you. Uh, we have done this or not till now? Okay. Good. No problem. Let's. So now we can load our data. Df is equal to p.read csv. You can pass it r.csv. Okay. And df, we are able to see the data. But the problem is over here that there is no any column name they have given. Okay. So I've created the separately the column name. I'm going to share with you guys as well. Okay. These are the column names. Right. You can give this column name over here. Once we'll download it, we'll give this column name, right? And we'll give here the names equal to nothing but the column names. So it will also take this columns. Okay, let's run it and let's assign this column names. So now if you can see, it will come with the column. Either what will happen, whatever the first row it is able to see, it will take it as a column. But we don't need that, right? Okay. So this is your data. You have a target column. In your target column, you have a total 4 classes. Okay. We have a 300 rows of the data over here. and you are going to work with this particular data. Okay. Now, what is this data? Let's try to understand this particular data. Okay. What is this data? What is the meaning of each column over here? And obviously, like it's a kind of a technical data of the healthcare. Will be not able to understand. Okay. Uh, what is this data and what is the meaning of each column over here? What kind of a data you have, right? Uh, so let's try to understand each in every column. So you will get more understanding about it. Okay. So first is the age. Age is the person age, right? Sex, it's nothing but male or female. Okay. So gender of the person. CP. Now CP is basically a kind of a chest pain type. Okay. So CP means chest pain, and basically there will be the different type of a chest pain. Okay. Individual have a different kind of a chest pain. So that's the type of a chest pain. Then we have something called a trust BPS. Okay, it's basically representing the resting blood pressure of the individual. Okay, which will basically the unit of it, the measurement of it, it's mmHg, millimeters of mercury. Okay, so it's kind of a crucial indicator. Okay, in healthcare reports. Okay, so uh, it will maybe increase the risk for the heart disease or something like that. So blood pressure is important. So resting blood pressure we can call it. Okay. Call is basically nothing but the cholesterol level of the individual. Okay. Then we have something called FBS. It's basically fasting blood sugar level of the particular person. Rest ECG basically resting electrocardiographic results. Okay, it might be like encoded in different types of abnormalities detect in this ECG uh, report. Okay, so it will basically provide an information about the heart's electrical activity and the potential cardiovascular condition of the person. Okay, then we have THEL-CH. THEL-CH is basically maximum heart rate achieved during the exercise or a stress testing. Okay, so what is the maximum heart rate the person have? Okay, that's the information over here we are getting. Then we have something called EXANG. It's basically exercise included angina. It is basically indicating that the particular individual experience any angina. Angina is nothing but the chest pain during exercise or something like that. So angina is basically during some exercise can be a symptoms of underlying heart disease, something like that. Okay. Then we have something called an old pick. It's old pick is nothing but it is representation the depression included by the exercise relative to the rest. If people are doing the exercise, what is the depression level of them and what is the uh, depression level uh, different when people are doing the rest. Then we have a slope. Slope is basically represent the slope of the peak exercise segment. Okay. So on electrocardiogram during some of the exercise, will test and provide some additional information about the presence and some of the uh, slope of the peak exercise. Then we have something called CA. CA is basically represent the number of major vessel colored by the something called it fluoroscopy. Okay, so it is basically indicating the presence and severity of uh, any disease based on the number of major blood vessels. Okay, so like blood vessels, basically if it is closed or something like that, that is maybe some disease or that. So it depends like what is the result behind it. We have something called thel, the last column, which is the represent the thalassemia. It's a blood disorder. Okay, thalassemia, it is present or not. And in the end, we have a target column. It will basically present the heart disease. 1 is indicating the presence of the hard disks. 0 is basically there is no any hard disks. 2 and 3 is basically different type of hard disks, right? So this kind of a data we have. Okay. Now target column we already have over here. So it's basically a supervised machine learning algorithm. Uh, and the target column which we have nothing but the four different classes 0, 1, 2, and 3. So it's a multi-class classification. Okay, we are able to see, right? So yeah, that's it, and we can now apply any of our uh, algorithm over here, the classification algorithm over here, right? Okay, cool. So let's try to figure it out, and let's try to work on it. Okay. I hope you all are able to understand the data set, right? Yes or no? Everyone is able to understand the data set? Yes or no, guys? Yeah. Okay. So yeah, let's do the practical now. Cool. So now very first thing is we'll do some of the data analysis over here, right? We have to do some of the data analysis. Uh, so we'll be able to understand that what all are the missing values we have in our data, right? Uh, what we have to consider as a null value or something like that. Okay, so let's take the info of the data to get to know about the data types and everything, right? So I'll ask you the questions. Okay, tell me, is there any null values we have in our data by looking at that info? Do we have any null values in our data? Yes, no. Any of the column have any null values? No. Okay, where you are able to see in null values? Which column you are able to see in null value? Or which column you are thinking there is a null values? Zero is the value, so it's not an issue. Okay. Okay. Let's consider about the data type over here. Which data type is basically a categorical data type over here? Okay. See, this both column is the object, right? Now, if you can see this both column, C and L, okay, we have a data which is the integer data, right? Then why it is showing us the categorical? You are able to see, like, you will get your answer over here only, okay, in one of the column. Can anyone tell me what is the issue? Just look at the data. Anyone? See here, question mark is there, right? So it means there is some problem, right? So basically we have to remove this, right? So let's identify what all the columns we have with this particular thing, the question mark. Columns with question mark, let's say. Okay. So we'll try to find out. Okay. So from the columns which we have, from the existing columns which we have, we'll find out that is any of the column, so is in basically any of the column. So to come like this, because we have to identify the column, right? So is in uh, kind of these values. So let's say this, right? If any of the values which we have, any of the column which we have, will get all these columns, the name of it. So we column is with um. So able to see there is a two columns over here which have this kind of value, right? So now what we will do, we will replace them, right? How we are going to replace them? So with the mode value of them. Okay, what is the mode? What is the mode? Anyone remember? Mean, median, mode. What is mode? What is mode? In a mean, median, mode. Most frequent number. Okay. Now call in columns with one. We'll find out the mode for each column. Df of that particular column. Find out the mode of it. Yep. Df dot lock, wherever we are able to see uh, any of these question mark, you need to replace it with the mode of it, right? So any of the column have this value, you can replace it for that particular column. You can replace it with the mode of it. Okay. Select the column. Yeah, I will make the change. Okay. Now if I can see this df.info, they are still object, but if we can see the df over here, there is no any question mark. Okay. But still, it's a categorical. So we have to basically uh, convert it. So we'll do it. No worries about it. Okay. It's still object, but we'll do it. Okay. Now what we can do is how we can uh, convert it into a particular integer format, right? So for that, what we can do is we can use the label encoder, right? So I told you about the label encoder. I think in the linear regression also we have talked about it. One hot encoder and the label encoder. I told you the difference between them as well. Okay. So from sklearn dot pre-processing, we can use the label encoder, which can make it as a integer. Okay, so from sklearn dot preprocessing, not command, import label encoder. Okay, we can define the label encoder over here, and then we can apply on both of the columns. So for CA, we can apply le dot fit transform. It's very simple, right? We can just give our data, okay, df of CA, it will do it for you, okay, for the CA, and second is the HAL. So you can do here only, and just copy it, paste it, and here instead of CA, there will be THAL or THAL. It will do for that. Now, if we can see the df.info, we'll be able to see it is already converted. See integers, right? Now it is an integer. No null values, nothing, right? So we are good to go now. Okay, cool. Now, let's see the description of the data, right? And you will tell me what you are able to see in this description of the data. Okay, so what is this describe? What all the things you are getting? You should tell me. Okay, analyze it. Take your 2-3 minutes and let me know what all the things you are able to see over here. Okay, what all this value you are getting. It's pretty easy. Try to get it. What all this value, how it is going to help you to understand your data. So from here you will get so many insights from your for your data. Let me know if you are able to figure it out. Anyone? Okay, see, what is the mean and median? Can anyone tell me the difference between mean and median? I'll help you to understand the thing. What is the difference between mean and the median? Both the value. What is mean? Nothing but the average of your data, right? What is the median? What is the median? Come on, guys, it's kind of a school things. Fifth, sixth class, you have learned about these things. What is the median? Anyone know what is the median? Median is the nothing but middle value of your data, right? It is simple. Okay. So for an example, let's say I have a five data point, right? If the mean and the median is different in my data point, can I say it's nothing but there is an indication that there is an outlier in my data? What is outlier? Do you know, guys? What is outlier? What is the meaning of outlier? Okay, let me show you something. Okay, let me share my screen. Okay, my board. Okay, let's say I have this kind of a data. Just a second. Yeah, let's say I have this kind of a data, right? Uh, okay, let's say I have this kind of a data. Okay, so what will be the mean of this data and what will be the median of this data? Can anyone tell me? What will be the mean of this data? What will be the median of this data? Quickly. 10.9. Yeah. Okay. What will be the median of this data? 7 plus 9 by 2, right? 9 plus 7 by 2. Okay. So it will be 16 by 2, right? Means 8 is the median. It means there is a change of between mean and the median. It means there is a outlier. Outlier. What is the meaning of outlier? Outlier is nothing but the unique value which you have in your data. Okay. Unique value you have in your data. Nothing but the outlier. Okay. So there is some outliers. Okay. Which will affect your result. So you have to remove basically the outlier. Now how you can remove the outliers? Okay. So outlier remove. So to remove the outlier, okay, it's a very pretty straightforward formula. IQR is equal to Q3 minus Q1. Okay, Q3 minus Q1. Once you will be able to find out the IQR, you have to find out the upper limit and the lower limit of your data. Okay, Q3 and Q1, what it is. So it's a 75 percentile of the data. Q1 is 25 percentile of your data. Okay, I have a network issue. Everyone is facing any problem or lag in audio or something. Everyone is facing any issue, um, lags in audio or something. It is fine, right? Yeah. Please check your internet. I think, Devendra, maybe you are getting some issues. That's why. Okay. So you have to find out the Q3 and the Q1 value of the data. Okay. So how we will find out that Q3 and Q1 value of the data, right? That is important. Okay. So you have to first of all, you have to find out the value of Q3 and the value of Q1 in your data. 25 percentile of your data and 75 percentile of your data. Okay. Anyone remember how to find out those values? It's pretty uh like when we was in the school, we have learned these things. That is a very simple formula if you remember. See, for the Q3, okay, we'll do something like this to find out the value. Okay, and then you will do the same thing for Q1 as well. Let me tell you. So we'll find out like this. Let me find here. Q3 value. So formula is very simple. N plus 1. It's a Q3. So that's why into 3 divided by 2. Okay. Q1. It's N plus 1. Okay. Into 1. It means the N plus 1 same value. Okay. Divided by 2 because it's a Q1. Okay. So Q3 over here, the N is nothing but the number of data points you have. So we have total 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 data points. Okay. So we'll find it like this. What it is. Yes. No, Q3. 10 values we have. 10 plus 1, 11. 11 into 3, 33 divided by 2. Okay. So 33 divided by 2. Okay. Q1. Simple. N plus 1, 11. 11 divided by 2. So this value will get. Okay. Now this is the Q3. Okay. Q3 will get basically 33 divided by 2. 33 divided by 2. 16.5. 16.5. Then we will again Q2. It will be something around 5.5. Right? Okay. So this two value which you got, it's nothing but your Q1 and your Q3. Okay. So now, oh, I'm sorry, I did a mistake. I think we have to do it by 4. Sorry. 33 divided by 4, 11 by 4. This will give you the position. Okay, let me write here again. Q3 basically n plus 1 into 3 divided by 4. Q3, then Q1 is n plus 1 into 1, it means no any meaning, right? Divided by 4. So, sorry, 10 plus 1 into 3, 33 divided by 4. Okay, Q1 basically 10 plus 1, 11, right? Divided by 4. So 11 by 4. Uh, so you will get this two value, which will be nothing but the position of your 8.25. Uh, Q3 and Q1. And this one is 11 by 4, 2.75. So it's position, okay. It's not the actual value. So 8 point, sorry, 8.25 means eighth position in your data point, it's your Q3. 2.75 means third position we can consider, nothing but your Q1. So this is your Q1, eighth position we can consider. So this 10th, ninth, this is your Q3. Mm. Okay. So it's your Q1, it's your Q3. You got both, right? Q3 and Q1. Just a second. Hmm. So once you will find out this Q3 and Q1, next step is finding out the IQR, interquartile range. Q3 minus Q1. Okay. So Q3 minus Q1. Now you got both the value Q3 and Q1. So Q3 is 15, Q1 is 3. So 15 minus 3, 12 is your IQR. Okay, but what I will do with this? Okay, so with this, I will find out two things, upper limit and the lower limit. Okay, how I can find out this now, upper limit and lower limit? So it's a pretty straightforward, simple formula to find out this upper limit and lower limit. Okay, but what's the work of upper limit and lower limit? I will tell you. Okay, so Q3, upper limit formula is Q3. Okay, plus 1.5. It's a constant value. You can keep 1.5 or you can keep uh, 1.25 as well. 1.5 into IQR. Okay. Here Q1 minus 1.5 into the IQR. Okay. So basically you will find both value, right? For this, I'm writing here Q3 is basically your 15. Okay. Plus 1.5 into whatever the IQR you have, which is 12. Okay. So 15 plus 12 into 1.5. Let's calculate this. Let me calculate for you. 1.5 into 12 plus 15, which is 33. It's your upper limit of your data. Okay, upper limit, lower limit. Lower limit basically Q1. Q1 is nothing but 3 minus 1.5 into the 12. So 12, 3 minus 18. No, I did mistake, I think. 10 plus 1.5 into 33. Okay. 3 minus 1.5 into 12, which will be minus 15. Minus 15 is your lower limit. Okay, minus 15 and 33. So now what you will do with this? So if you have any value which is greater than the upper limit, okay, uh, value, let's say n is the value which is greater than the upper limit, you will remove it. Okay, and the value which is less than the lower limit, you will remove it. Okay, so The values which is more than this upper limit we can consider as outlier. Values which is less than the lower limit is the outlier for us. Okay. So are you able to see any outlier in this data which I have given to you? Is there any outlier in this data? Yes or no? Is there any outlier in this data? No, right? Yeah. So there is no any outliers in your data. But if here, if I can consider 50 and then I will calculate everything again, I'll get the outlier. Okay. So 50 will most probably it will be on your outlier, right? So this is how you will calculate which value is basically your outlier and you can remove that. Okay. Understood everyone? What is outlier and how you will calculate it? Yes or no? Any doubt? Anyone? You all are able to understand how to find out the outlier in your data and what is exactly the outlier is? What's the mean? What is the median? Everything understood? Everyone? Yes? No? Yep. Okay. Okay. Cool. So, yeah, we have to do the same thing practically, right? So we'll implement the same thing in our practical and we'll see how we are going to do it. Okay. So it's pretty simple as we have done this mathematically. We are going to use the same formula to find out all these things and we can just put it into the Python. That's it. Very simple. Okay. So, and then we can remove it. That condition we can write. Okay. Cool. So, any question? Anyone? Any doubt? Any question? Anyone? Last part. What you are not able to understand? The upper limit and lower limit? Is it? See, there is a formula for upper limit. This is the formula Q3 plus 1.5 into QR, right? We'll find out this value of the upper limit. As of now, you have got the upper limit of 33. Okay. Now this is the upper limit. This is the maximum limit of the data you can keep in your data according to your data. If you have a value which is more than the 33 in your data, you can remove those values. Let's say 35 is there in your data. You can call it as an outlier. So you don't require the outlier in your data because it's a value which is unique value from the existing data point, which will be one or two, right? Not more than that from the existing data. So you can remove that value. Similarly, you will find out the lower limit with the help of a Q1 minus 1.5 into the IQR. If is there any value which is less than the minus 15, let's say minus 16, minus 17 is that. Okay. So you are going to remove those particular values from your particular data. Okay. Got it? I'm still confused. Yeah. Okay then. Let's meet into the next session and we'll practically implement the same thing. Okay. Cool. Yeah. Thank you. Thank you everyone. Bye. Have a good night. Yeah, thanks. Thanks.